Hello everyone. In this video we are going to talk about what is electron affinity, what are the different types of electron affinity, and what is the nature of electron affinity. Okay, let's start the video. First of all, you must know what is electron affinity. Electron affinity is an enthalpy change, and this enthalpy change is related to which process? This enthalpy change is related to the process of reduction. Whenever an atom gains electron, that process is known as reduction, and during this process the enthalpy change, the energy involved, it is known as electron affinity. So generally speaking, you can say electron affinity is the enthalpy change for the process of reduction. Electron affinity is the enthalpy change for the process of gain of electron. Second thing, how many different electron affinities are possible for a single atom, for a single element? So remember, number of electron affinities for an element depends on number of unpaired valence electrons. As you know, an atom can gain how many electrons? It depends how many total electron it has in the valence shell, and out of the total valence electron, how many electrons are unpaired electrons? Those unpaired electrons take part in chemical bonding. Now what does this mean? Let's take the example. If you look at sulfur, you people know sulfur belongs to group number 6. So in the valence shell of sulfur there are how many electrons? There are 6 electrons. If we distribute 6 electrons in the valence shell of sulfur, what is the common way to distribute electrons into the valence shell? 1, 2, 3, 4. First we distribute electrons in unpaired form, then we start their pairing. Now electron number 5 will pair up one electron, electron number 6 will pair up another electron. Now what you can see in the valence shell of sulfur, how many unpaired electrons are there? There are 2 unpaired electrons. It means how many electron affinities sulfur can have? Sulfur can have 2 electron affinities. Why 2? Because sulfur will gain one electron, that will be known as first electron affinity, but after gaining one electron, the valence shell of sulfur will not be completed, so sulfur will gain one more electron. When sulfur will gain the second electron, that electron affinity would be known as second electron affinity. So for sulfur, how many electron affinities are possible? 2. Let's take another example. Chlorine, you people know it belongs to group 7. How many valence electron it has? It has 7 valence electron. In its valence shell there are 7 electrons. If we distribute 7 electrons, what you can come to know? How many unpaired electron chlorine has in its valence shell? In its valence shell it has one unpaired electron only, so it means it needs to gain one electron only to complete its valence shell. That is why how many electron affinities are possible for chlorine? Just one. So now what I want to say, you would have understood that how to find number of electron affinities for an element. For example, if I give you phosphorus, it's a group 5 element. Quickly, can you guess how many electron affinities it would have? Yes, you are right. It would have 3 electron affinities. Why? As I told you, phosphorus belongs to group number 5. It has 5 valence electron. After distributing these 5 valence electron, we come to know that it has 3 unpaired electron. So phosphorus can gain how many electrons? 3. When it will gain first electron affinity. When it will gain second electron affinity. And after gaining the third electron, it that electron affinity would be third electron affinity, and the valence shell of phosphorus would have been completed after the gain of 3 electrons. So this is how you can find total number of electron affinities which are possible for a given element. After that, now how, if ever you are asked how to write down an equation for electron affinity, remember electron affinity is related to the process of reduction. Reduction is the gain of electron. Electron is written on the left hand side of the arrow generally during reduction. For example, if X is an element, X gains 1 mole of electron, it will become uni-negative ion. Look at the change in oxidation state. Before the reaction, before the gain of electron, X had a charge of 0, but after the gain of electron its charge is 1 negative. So whenever there is a change from 0 to 1 minus, it means that element has gained first electron. So you can clearly, you can obviously guess that this is an equation for the first electron affinity. Now based on this information, I'm sure that you people have become able to write down an equation for the second electron affinity. What you will have to do, from where you will start for the second electron affinity, x1 minus, and after gaining 1 mole of electron, x uninegative ion must have become x dinegative ion. So that is why this equation represents second electron affinity. Now comes the third electron affinity. If an element is going to gain electron number 3, so from where we will start? We will start from x2 negative, gain of electron, it would get a charge of 3 negative, trinegative ion. So this represents third electron affinity. So some of you might be thinking that what if an atom starts from zero oxidation state and gets in one step 3 negative charge? It's very simple. Why? Because it means you have shown how many electrons have been gained by that atom simultaneously? 3. So it means whenever an atom it shows a change from 0 to 3 minus, 3 negative, it means it has gained 3 electrons simultaneously. So you will have to write down that equation represents 3 electron affinities together. You will write down delta H EA1 plus EA2 plus EA3. So this is whenever we add more than one electron, we add up the number of electron affinities. Okay, next comes how you can define electron affinity. Whether you are asked to define first electron affinity, second electron affinity, or third electron affinity, if you have these equation in your mind, definition is not a problem. Let's see, I'm going to define first electron affinity and you will come to know. Just keep in your mind the equation for the first electron affinity and you will see I am going to give the wordings only to this equation. That's it. See the definition for the first electron affinity. How you will start? You will say the enthalpy change when 1 mole of electron is added to 1 mole of gaseous atom to produce 1 mole of gaseous uninegative ion. This is first electron affinity. Now likewise, you can yourself define second and third electron affinity. Could you give it a try? Okay, try it. Just pause the video and try to write down the definition for the second and third electron affinity. But remember, in the second and third electron affinity, we are having dinegative and trinegative ion. I am telling you the definition for the first electron affinity again. It is the enthalpy change when 1 mole of electron is added to 1 mole of gaseous atom to produce 1 mole of gaseous uninegative ion. Write down for the second and third electron affinity. Okay, if you people have written or at least in your mind you have revised how to write down definition for the second electron affinity and for the third electron affinity, you can check it with me. I'm telling you the definition for the second electron affinity. It is the enthalpy change when 1 mole of electron is added to 1 mole of gaseous uninegative ion to produce 1 mole of gaseous dinegative ion. And likewise, third electron affinity is the enthalpy change when 1 mole of electron is added to 1 mole of gaseous dinegative ion to produce 1 mole of gaseous trinegative ion. You got it? Great. Okay, moving on. What you must remember, what is another important information about these electron affinities? You must remember what is the nature of these electron affinities. So remember, only first electron affinity, it is exothermic. It releases energy, while all other electron affinities, they absorb energy. They are endothermic. So generally, what you can remember, except first, all other electron affinities are endothermic. Okay. So what you should remember? You should remember first electron affinity is always exothermic, the second and so on, they are always endothermic. What is the reason behind that? I'm going to explain that. See, whenever electron is added to any atom or any ion, two forces are operative. One is force of attraction, other is force of repulsion. Electron, it is attracted by the nucleus of an atom. That is the force of attraction. Force of attraction releases energy, and there is a repulsion between electron and the valence electron already present in the last shell, in the outermost shell of the atom. They cause repulsion to the incoming electron. Repulsive force absorb energy. In the first case, force of attraction is greater, force of repulsion is lesser. Energy released is greater than the energy absorbed. That is why overall this step becomes exothermic. But what happens in the second and so on, other steps, electron is gained, is being added to negatively charged particle. Negatively charged particle can create greater repulsion. So in the second and third electron affinities, the repulsive force dominates attractive force. Energy absorbed, it becomes greater than the energy released, because inter-electronic repulsion is increasing. And even in third electron affinity, inter-electronic repulsion will be much more compared to attractive force. So repulsive force dominates to a considerable amount in third electron affinity. So energy absorbed is much greater compared to the energy released. So remember simply what you can remember, why first electron affinity is exothermic while all other electron affinities are endothermic, because repulsive force, it dominates the attractive force due to inter electronic repulsion. Okay, what you can remember more, that if we look at the sign, beside signs you can also guess the magnitude. If I assume that the first electron affinity of an element is minus 20 kilojoule per mole, the second would not only be positive but it would also be greater in magnitude, and the third one, even its magnitude would increase to a considerable amount. Why? Because negative charge has increased to 2 negative. Greater negative charge, greater interelectronic repulsion, and more endothermic will be the electron affinity. Based on this, what you must remember, if you have been given first electron affinity of any element, first electron affinity of any element is always exothermic. But if you have been given first and second electron affinity for any element, first and second electron affinity, the sum of first and second electron affinity for any element is always endothermic. And likewise, if we add up first, second and third electron affinity, the sum of first, second and third electron affinity for any element, it is also always endothermic. I hope you would have enjoyed this lecture. Thank you for your time. Bye for now.